All right, so we're going to talk about isosceles and equilateral triangles. We talked about isosceles the other day in class, but I just wanted to make it more formal. You can take these notes or not. I have uploaded with this video a notes sheet you can use that's already drawn, but you don't have to. Just you need to know these things. So see where it says things to memorize. You actually need to know these and be able to apply them and look for them within different shapes. So the first thing, and these are all the things we kind of talked about in class, base angles, which is the only one we didn't talk about. These are the base angles, and they are congruent. Remember, congruent means exactly the same. So if this is 20 degrees, that's 20 degrees. If this is 50, that's 50. The height of an isosceles triangle is a perpendicular bisector of the base. And I just want to remind you that that is the symbol for perpendicular, and that perpendicular means that it intersects at 90 degrees, and bisect means cut in half. So the two little pieces at the bottom are actually congruent from here to here and from here to here. And also the height bisects or cuts in half the vertex angle. So that would be marked like this to show that those are congruent. And we'll use that in many ways throughout time, so you just need to make sure you have that memorized. For an equilateral triangle, all of the angles are congruent, just like all of the sides are. If all of the angles are congruent, that would be 180 divided by 3, which is 60. So you can just remember that in an equilateral triangle, the angles are each 60 degrees. But I'm going to put the congruent marks just for reference into the angles. And again, just like with an isosceles triangle, the height is a perpendicular bisector of the base, but it also doesn't matter which way you turn it because, you could have one this way, you could have one this way. It works the same in all directions. And the heights bisect the angles just like in isosceles. So basically, equilateral is kind of a special isosceles. All right, we're going to do 3 examples and be done. So the first example doesn't say in words that it's isosceles, but it does show us 2 congruent sides, in which case we know that it's isosceles. The important thing to know is that the base angles are always opposite from the congruent sides. So this angle and this angle are the base angles. And base angles are congruent. That was one of the rules. Congruent means equal, which means, so I'm going to write it like this. Angle B is congruent to angle C. If you want to change it to equals, it would kind of look like the measure of angle B is equal to the measure of angle C. That's how congruent and equal are related. And now we're just going to fill in what we have. We know that B is 4x plus 7, and it has to be equal to 9x minus 33. And then from there, we just solve. Again, there's 4 places you could start here, but I'm just going to solve it myself. If you have any questions about solving equations, just let me know. So we know that x equals 8. And since this one I didn't specify, if I wanted to know how big the angles are, you could just leave that as the answer. But I do kind of want to talk about how that plays into the rest, because a lot of the times this kind of question will say, what's the measure of angle A? Well, A has nothing in it right now, so we're going to need to apply stuff we've known from before to this problem. I'm going to pull out the calculator just for ease. We know x is 8, so in order to find the measure of angle B, we need to substitute 8 for x. So hopefully you can see what I did there. And that angle is now 39 degrees. Now hopefully we did everything right. And when we substitute 8 into our other angle, it also equals 39, which it does, which means we did our algebra correctly. But how could we figure out the measure of angle A? Well, we know that the angles in a triangle add up to 180 degrees. And we have two 39-degree angles to subtract. So 180 minus 39 minus 39 is 102 degrees. So the measure of angle A, 102. Let's look at the next problem. In triangle DEF, well, we don't have one, so we're going to draw one. If the angle D is congruent to angle E, DE equals x plus 4, EF 4x minus 8, and DF 7x minus 35. Find the measure of each side. Does anybody know, think about it for a sec, which angle in this picture is the vertex angle? The vertex angle is angle F, because the vertex angle is all by itself, it's alone. The opposite angles, base angles, are across from the congruent sides. So now we have these two sides. Now, a lot of people want to add these up and set them equal to 180, but they are not angles. So we cannot do that. We need to say, okay, well, I know that these two sides have to be the same. So I'm going to set up an equation. 4x minus 8 equals 7x minus 35, because these two sides are the same. And again, they're the same because they are the opposite ones from the base angles. We're going to solve that. And we get x equals 9, or 9 equals x using the symmetric property. All right, it asked us to find x, so that's part of our answer, but it also wants us to find the measure of each side. In order to do that, you're going to substitute x, 9 for x. So here we have 9 plus 4. This side is 13. We have 7 times 9, which is 63, minus 35 is 28. And 4 times 9 minus 8 is also 28. So you can see we did it right. Our two congruent sides are actually congruent. And that's it. So draw a picture, label everything you know, look for the relationships you know, and then continue. So in this one, this is an equilateral triangle. And if it's equilateral, that means also it's equiangular. So you could then know that all of the angles are 4x plus 8. But I'm going to write it like this just because I think it's easier. There are 3 4x plus 8 angles. And in a triangle, the angles add up to 180 degrees. But you could also just add them up, but I'm doing it this way, and distribute. 12x plus 24 equals 180. I think that's 13. Yeah. All right, find x. X is 13. Interestingly, you cannot figure out anything about the sides of this. We know they're the same. There's no way to figure out how big they are because we don't have any side information. All right, that's it. Enjoy.